Are you looking for ways to manage pests and also improve the soil health on your farm? Well, today we're going to be talking about Integrated Pest Management, or IPM. We'll show you what it is and how it works and how you can get support from the USDA's Natural Resources Conservation Service to help implement it on your farm.
Hi, my name is Sisson. I work for Iowa State University as part of the Integrated Pest Management Program in the Department of Plant Pathology. I'm here today with Ian Olson, who is an Environmental Services Manager for Centrol Crop Consulting. One of the things that he does in his job is to help farmers implement 595 standards as part of their equip plans on their farms. Will you give us kind of a high-level overview of what a 595 plan is?
Yeah, so the 595 Integrated Pest Management Plan looks at a farm operation and takes into consideration, all the things they're doing to manage pests on the farm. That could be weeds, insects, diseases, and really looks at all the ways that they can manage those pests on the farm. So that's looking at not only the herbicide or insecticide, fungicide applications, but looks at things like cultural practices, tillage, crop rotations, alternative tillage practices, those types of things that they can implement on the farm to manage those pests and not rely solely on pesticides as a form of pest management.
So what are some of the benefits of not relying solely on pesticides?
Yeah, so I think the biggest benefit that we've seen is, as you know, in the ag industry, we've been very reliant on pesticides, and we're starting to see pesticide resistance in a lot of the weeds and even in some of the insects that we're trying to control. So finding ways to manage those pests without being 100% reliant on the herbicide or fungicide applications does bring a value and a benefit. It's also potentially a cost savings to the producer as well if they don't have to spend the money on some sort of pesticide, and we can manage that through tillage or crop rotation, and just brings a little bit more diversity to the farm. And then from the NRCS's perspective, it does have an environmental benefit. We're not using as many pesticides in the environment. We don't have as big a concern with groundwater issues, runoff issues, those types of things. So it really does bring a lot of different values when we look at the whole farm scale.
Great. So there's potential environmental benefits, there's cost savings, which everyone is looking for these days potentially, and then there's also preserving pesticides for when they're really needed on a farm so that they will do what they're supposed to do when you need to call them into action instead of just using them all the time.
Absolutely right, correct.
So you write plans all the time. Can you give us an example of what that looks like?
Yeah, so typically when we identify a producer comes to us that wants or needs a pest management plan, we'll sit down with them. Usually we'll start by looking at the fields that they operate, number of acres, that type of thing. Look at what they already have out on the farm as far as erosion controls, what their tillage practices are, just try to get a feel or an understanding for how they're operating currently. We usually ask them about their current herbicide programs and those types of things, and then also visit with them about technologies that they're adopting on the farm, specifically pertaining to pest management. And once we kind of gather that information, then we can go back and follow NRCS's practice standard to run all the different models for erosion, for herbicide interactions with the soil, those types of things. And then once that's all compiled, we can go back to that producer and help them identify things that they can change. So, most of the time it doesn't necessarily result in going away from a pesticide completely, but maybe we change a mode of action, or we look at a different chemistry class, depending on what their weed pressures or their insect pressures are. But then we also have the discussion around, how can we manage our tillage better to control particularly insects and maybe fungal or airborne diseases, and really just take a more holistic look at what we can do on that farm. And then, they kind of make the decisions on what practices they want to implement, and then we move forward year over year with those. And, those documents are kind of living, so we put a plan together, and what we think we might want to implement, maybe 2 or 3 years down the road that gets changed. And we just are constantly looking for new things that we can bring to the farm.
So a farmer might look at some of the plan requirements and think that it might be kind of daunting to implement them on their farm. Is there a high barrier to implementing some of these?
You know, I think the key to being successful with these programs, you know, there is a lot of paperwork. There's a lot of documentation. It is probably at face value a fairly daunting task. I think the key to success with any of these programs is getting the right people at the table. So where I've seen these plans be the most successful, you know, a lot of times you're incorporating an agronomist, you're incorporating for sure the farmer. A lot of times you're bringing some environmental professional, NRCS type staff to the table, and you're having a collective conversation so that everybody that's involved understands what the ultimate goal is, and then everybody takes a piece of that puzzle in their area of expertise to kind of bring it together. And I think if you try to handle these individually or without the right people at the table, then it's definitely a daunting task. But bringing the right people, it can go very smoothly.
So you want to utilize the expertise
Absolutely.
of a group of people to get these things done.
That's absolutely right. You got to have the right players on the team.
Great. So tell me what you have accomplished through some of these plans on farms.
Yeah, so it's kind of the rewarding piece of it is, you know, a lot of times producers think, you know, we can get into these programs and they see the financial assistance piece to it. They see the dollar per acre, and that's really what they're driving after is I can make a little bit of money on this. Well, that's definitely a great benefit, and that financial assistance definitely helps offset some of the costs to get the right people and the right technologies to the table. But when you can actually work with that producer to implement those practices, and you do see after 6 months or a year that they come back to you and say, you know what, we implemented this plan and we bought the technologies for the sprayer and we saved 30% on our chemical bill last year. Or you visit with them and they say, hey, we got rid of the old disc ripper and we went to a more reduced tillage to manage some of the erosion, and you know that's saved on our fuel bill. And you have those follow-up conversations with these producers and you hear the success stories. That's when it finally clicks for you that we accomplished something and it wasn't just a checkbox exercise to get a few dollars in the bank account. So that to me is a success, or the reward at the end of the day.
All right, so it sounds like there are benefits beyond just monetary.
Absolutely, absolutely. I mean, you know, we talk about, you know, the farm economy right now and where dollars and cents can get spent, and you know what it costs to produce. I mean, anywhere you can bring monetary value, whether that's increase yield, decrease expenses, bring some sort of value or change to that farm that producer sees at the end of the day in the checkbook, and it brings environmental benefits, well, that's a win-win for everybody. So really becomes a no-brainer when you start to see those actually play out.
So if someone is looking to do this on their own farm, what are some resources? Where do they go? Where do they start?
Yeah, the best place to start is obviously the NRCS office. Those folks are there to help guide them in the right direction. You know, usually if you have an idea in your mind, even if you don't understand what the practice number is or exactly what it's called in their manual, if you explain to them what you're trying to do, they can get you pointed in the right direction. University extension in certain states especially are really tapped into what resources are out there. I think that's a great place to start. And then, you know, otherwise crop advisors, a lot of crop consultants, crop advisors out there are familiar with these programs, especially if they're working with a lot of producers. They probably had some exposure. So if you're working with somebody in that capacity, bring it up to them and hopefully they can get you pointed in the right direction.
Great. Well, thank you very much, Ian.
Absolutely. Appreciate it. Thank you.
Hi, I'm Deana Knuteson. I work out of the Department of Plant Pathology at the University of Wisconsin-Madison, and I work with the Integrated Pest Management Program out of the UW.
Hi, I'm Daniel Smith, the Nutrient Pest Management Program Manager at the Division of Extension, University of Wisconsin-Madison. Deana, what are some examples of IPM and what's the definition from NRCS?
Oh, that's a great question. IPM overall is Integrated Pest Management, and it's taking the whole toolbox and putting all of the strategies together to manage pests. It's not using one thing, it's using the whole bunch of tools out there. It's using the cultural, the physical, the all the management strategies. It's using trap cropping, it's using biological, it's using the systems as a whole. It's not just looking at it within the 1 year, it's looking at it as a multi-year, it's looking at it as multi-species, it's looking at the interactions between the weeds and the disease and the insects, and it's looking at it rotationally, it's looking at it at a landscape level, it's looking at the natural landscapes and how it interacts. And it is using the whole systems approach to manage pests. IPM is not a new concept. It's been around for a long time. As a matter of fact, before it was even defined, farmers were using it as a way to manage their pests, to try to plant when the pests wouldn't come in to be a problem for it. But IPM formalized through the USDA in 1972 to develop the IPM program as it is today. Now, integrated pest management strategies now, you will hear, are all out there, and you'll hear them through insect disease weeds, as you will in this series as you're going through. But we want to look at it as the holistic approach and how we can link it to NRCS programs and how there might be some cost share options that people can get through doing some options to get some money for starting some IPM programs.
IPM is a systems-based approach that means moving away from one single tactic towards many. As weed scientists Rodrigo, Werle, and Daniel Smith explain, it's about using many little hammers instead of one big one.
Hello folks, my name is Rodrigo Werle and I'm an associate professor and the extension weed scientist at the University of Wisconsin-Madison, and today we're here at beautiful Lancaster Agricultural Research Station in southwest Wisconsin.
Hi, I'm Daniel Smith, the Program Manager for the Nutrient Pest Management Program at the Division of Extension, University of Wisconsin-Madison. So in corn and soybean production, what are some of those examples of weed management practices? And then how do they relate to the natural resource concerns?
That's really good, Dan. So, corn and soybeans, when we think about weed management, herbicides are our big hammer, right? So when we're thinking about weed control, herbicides are our to-go tool. One of the challenges with herbicide, as you see behind us here, is herbicide resistance. So that's a scenario where we relied too much on that big hammer, and that hammer, the handle of the hammer kind of broke, right? So we have issues now, right? The other strategy that we use a lot for weed control is tillage. So tillage is a common strategy that farmers will deploy pre-plant, so then they can start their season clean. So tillage and herbicides are commonly used strategies for weed control, okay? They're quite effective. Farmers have become very, very efficient through the use of tillage and herbicides in order to manage their crops. The challenges that we have there with tillage and herbicides, some of the concerns as far as natural resources go, herbicide runoff is a concern, herbicide drift and off-target movement is a concern. And when you're talking about tillage, right, Dan, that's your area of expertise as well. What is the concern with tillage as far as soils go and natural resources?
Erosion, movement of that soil into the water, that soil's carrying phosphorus. That phosphorus can cause greater damage to the environment quickly.
Exactly. So again, the runoff, that erosion ties to water quality concerns there. So those are some of the challenges that these tools present to the natural resources.
So how are some strategies to help reduce those impacts to those natural resources, Rodrigo?
That's excellent. So this is where we start getting to the little hammers, right, Dan? This is where we get into the integrated weed management portion. For a while here, managing weeds was very easy. We could use, for instance, Roundup or glyphosate worked quite effectively, right? So it was hard to go away from that. But because of resistance now, I think farmers are rethinking their weed control programs, and we also have the natural resources in mind. So what we're trying to promote across the landscape is the use of, again, goes back to my analogy there, multiple little hammers. We want all those little hammers kind of working together to tackle the problem. When you have multiple little hammers there, even if something goes wrong, you still have those other hammers kind of still acting on it, okay? What are examples of integrated strategies that we can use? We have been doing a lot of work here in Wisconsin. We have high adoption of that strategy, which is cover crops, right? The use of high biomass cover crops. So through our research here, we have learned, right, Dan, that high biomass cover crops can really help with weed suppression and be part of an integrated program. What is the other benefit of cover crops for cropping systems, Dan?
Helps hold the soil in place.
Yes.
So the deep roots of the cover crop help hold the soil in place. We plant our cover crops even after corn and soybeans in the upper Midwest. We get some decent growth, sometimes in the fall, but more than likely in the spring. April, early May, we get accelerated growth, nice stand of biomass to plant into, and that's holding the soil in place. And we've seen some pretty drastic cases of that in the driftless region of holding soil in place by the cover crops compared to those farmers using tillage. It makes a big difference. It also makes a big difference with weed control. As you were explaining, we're seeing that biomass provide a mat like a mulch, really helping to suppress troublesome weeds like water hemp.
That's excellent. So again, a win-win there. Bringing cover crop into your system can help with the soil health aspect. But if you're managing those cover crops properly, you also get tremendous weed suppression. So that's an example here of an integrated strategy. The other strategy that we've been talking a lot about, especially for soybean farmers, is to adjust the row spacing, right? When you have 30-inch row spacing, just like the ones we have here behind and in front of us, it takes a while for that soybean crop to close canopy. Whereas when you go to narrow row spacing, whether it's 20 inches, 15, or you're drilling at 10 or 7.5, canopy closure happens very, very fast, and that helps suppress some of the late season weeds such as water hemp. So that's another example here, another integrated strategy that can be used, just adjusting the row spacing. There's one more thing, Dan. We're here, it's October already. We're getting to the end of the season. Farmers are going to start harvesting. They're already harvesting their crops around us here. What is the one thing you've been talking a lot about, Dan, this time of the year?
Yeah, managing weed seeds that move through combines. So, for example, a water hemp plant contains about 90% of its seed still. When we hit that plant with a combine, that seed comes off the plant, goes into the combine. Some of it falls on the ground right at the base of the plant. The stuff that moves through the combine, then some of it gets lodged in the combine. We're not too worried about the stuff that blows out the back. We're going to have to manage those weeds next year. That's something we need to really be thinking about preventing, of course, is weed seed production in general. But once it gets into the combine, there's some simple things that we can do out in the field before we move on to that next field that may be a lot cleaner, or maybe a neighbor's field that we're custom combining to help reduce weed seeds. Blowing off the head with a leaf blower, dumping the rock trap, cleaning out the feeder house goes a long ways to helping minimize that weed seed movement.
So again, I think the message here, integrated weed management more than ever because of the herbicide resistance issues that we're having out there are and will continue to be incredibly important. And I think the beautiful thing here is as we start bringing these integrated strategies, as we talk about cover crops, we talked about row spacing, we talked about like being strategic with harvest, cleaning your combine to reduce the spread of weed seeds. All that together, what that does is going to lower the weed pressure in future years. And when you're lowering your weed pressure in future years, you're reducing the reliance on both tillage and herbicides. Okay, and that goes back to the beginning of our conversation. If we can reduce the reliance on tillage and herbicides, we can also protect the natural resources that way, and hopefully the farmers will also be seeing long-term ROI in all that, helping them with their bottom line here at the end of the day.
Scouting fields is a fundamental practice in integrated pest management for managing weeds in corn and soybean fields. By regularly and systematically monitoring the fields, farmers can identify weed populations that may be resistant to herbicides, weed escapes from herbicide application, and weed growth stage, enabling targeted interventions. This approach reduces damage to non-target organisms and may help to protect the environment and promote human health. Scouting fields for weeds and keeping track of what you find can help inform management tactics for this season and for future seasons. If weed escapes are identified, spot treatments can be applied to specific areas of the field. Even if only a small area of a field has weeds that are allowed to go to seed, it can add a substantial amount of weed seed for potential future outbreaks. If weeds are allowed to grow in a field unnoticed, they may become too large to be effectively managed with herbicides, or the crop growth stage may be at a point where herbicide application is no longer on label. Ensure spray equipment is correctly set for optimal weed management and conduct follow-up field scouting to ensure targeted weeds are effectively controlled. Keeping track of what you sprayed and how it worked can help you select a different mode of action for the next field season and possibly avoid herbicide carryover injury. Additionally, subscribing to university crop newsletters can make you aware of important weed issues like invasive species or weeds found to have herbicide resistance. These practices align with various NRCS 595 standards for routine scouting, utilizing land-grant university information, reducing risk of resistance,
localized herbicide spot treatments, maintaining spray records, and determining treatment effectiveness through follow-up scouting.
This same principle of using multiple tactics also applies to disease management as well, but it all starts with a concept known as the disease triangle.
All right, my name is Daren Mueller. I'm an extension plant pathologist at Iowa State University, and today we're going to be part of a video series looking at IPM, integrated pest management, and sort of how that fits into conservation programs. And this focus, or this segment, is going to be around plant diseases.
My name is Adam Sisson. I'm an extension specialist for the plant pathology, entomology, and microbiology department. We're standing in a soybean field right now. What's an example that you can give us of a plant disease in soybean?
Yeah, and well, it's just not a soybean field. This particular field is actually a white mold nursery. And so if you look around, like, obviously we're at the end of the season here, but there's some plants, we put a lot of inoculum out. We're trying to get as much disease as possible. And so whenever we think of diseases, we think there's three things. And that's the plant disease triangle. You have to have the pathogen, and that pathogen is Sclerotinia sclerotiorum. You have to have the right environment, and so for white mold, that's usually cool and wet. And then you have to have a susceptible plant, and that's what we're here. We're evaluating hundreds of different lines to see which ones get more or less disease than the other ones. And so, yeah, so we're going to use white mold as sort of the example for this particular video.
Okay, so living organisms have a life cycle. Insects have a life cycle. Mammals have a life cycle. What's the life cycle of the organism that causes white mold?
Right.
Tell us about that.
Well, and actually, the knowing the life cycle is probably a good first step into IPM, because essentially when you look at the disease cycle or the life cycle, you sort of try to find the weak points in that to try to identify what to manage, what not to manage. And so for white mold, it's pretty easy. There's like 3 or 4 different steps. It starts out as surviving as sclerotia. And I like this disease because we describe these as sort of rat turd type little structures, and anytime you can use the word turd in a video, that's a good thing.
Especially in science.
In science, yeah. And so they survive as sclerotia, and these are essentially like the seed for the fungus. And then when the sclerotia imbibe or take in water, they'll actually germinate and produce an apothecia, and that's a little mushroom-like structure. That apothecia will then produce spores. The spores will move to the soybean plant, and they actually infect the soybean flowers. And then once they do that, they'll actually produce the white, fluffy mycelial growth, the fungal growth, and that's where it gets its name, white mold. And once it does that, and then it sort of establishes on that plant, as the season goes on, you can actually see the stems get pretty bleached, and then you'll see sclerotia actually growing back either inside the stem or outside the stem. Those fall on the ground, and then the next time soybeans are planted, that cycle is repeated.
So how long do they survive in the ground?
Well, and that's sort of, yeah, so like, okay, that's a good question, but like, let's just take a step back and look at the whole cycle. Like, okay, so what are the parts that you could maybe manage in an integrated pest management? The sclerotia would be one, and so they can survive for years. Given it a number, like I've heard 8, but I've been in fields where somebody's like, I planted corn for 20 years straight, and then they have white mold. So it's much more than 8, but there's probably a lot we can tease out there. But so when I'm thinking about integrated pest management, I'm looking at the sclerotia, apothecia, spore production, and then sort of the protecting that plant, and those sort of those are the steps that I'm going to be trying to tackle. So really it comes down to, okay, so like sclerotia are going to survive in the soil, so there might be ways to kill off the sclerotia while they're in the soil. So that would be one example. But it also, you need to have the right environmental conditions for the sclerotia to turn into apothecia. And so for that, you need to have wet, because that takes in the water and does it. But you also have to have the right light conditions. So once you get a good shaded canopy, then you get the right conditions for the apothecia to develop.
So when the soybean rows grow together and the
When
sunlight's no longer allowed
Yep.
in and the air is still, that's the kind of thing
That'd be ideal. And so you can sort of think, in Iowa here, early June, the plant, you can see the rows, it's really easy, there's still a lot of sunlight in between the rows. That's not going to be ideal. But once that canopy closes, those two rows grow together, that's going to be ideal. Now you start thinking, okay, well, is there some way you can open up the canopy? So you start looking at row spacing. So narrower rows, you're gonna close that canopy quicker. Wider rows, you don't. And so that it's not fail safe, but that's one way to reduce the risk. Plant population would be another one. A higher plant population, we close it a lot sooner than a lower plant population. And there's, fertility management. So high nitrogen, like a lot of farmers that put on pig and cow manure, they're gonna maybe see a lot more of that vegetative growth early in the season, and that will close the canopy, and that could increase the risk. And so you start looking at what are the ways to maybe reduce the risk. That's the start of an integrated pest management program.
So reducing that risk, though, that may come with some trade-offs, right? If you increase the row spacing or decrease the row spacing, you might have other issues. Or if you decrease or increase the population, you might not get the yield that you want. How do farmers deal with that?
That's why this disease is probably one of the more problematic. You just described it. So like if you were a weed scientist talking to me, they'd be like, no, narrow the rows. We want to get rid of water hemp. We want to try to, there's advantages in narrowing the rows. Agronomists would say get those rows narrowed as quick as possible to maximize yield. And sometimes there's give and flow, there's the give and take with different disciplines. And so if you have a really bad white mold problem, you might need to make some sacrifices in other weeds or the even yield potential. And if you don't have a white mold problem, well, then you have a different decision-making process.
So bringing this back to IPM then, it's really about knowing the risk in your own field, having that information, and letting that tell you how to choose or the right management practices.
Right. Yeah. So you're taking education, you're looking at that life cycle, the disease cycle, and you're trying to figure out what's the best practice for that particular field.
Okay.
Perfect. Yeah. So then now we haven't really talked about the two main reasons or main management strategies for white mold. It would be variety selection. So again, we're standing in a field where we're testing 1,000 lines. And so you do want to start, if you have a high risk for disease, you want to start with the most resistant variety possible.
These has different genetics. Each
row is a different line, and so yeah, you want to pick the most resistant line if it's available, if it makes sense for that field, etc. The second thing is, and sort of the last ditch effort would be fungicides, and so we haven't really talked about that, but a lot of times people think IPM and they're thinking, well, how does that, what's the best practices for pesticide use? That's not necessarily the case, because sometimes we want to avoid the pesticide completely. So, but fungicides could be an option. And so it's making sure you get it out there at the right timing, using the right product, using the right rate, etc. So,
why are farmers so concerned about white mold? Is it just an occasional disease, or can it wipe out a field?
It definitely can wipe out a field. And it just depends on how early or what are the right conditions for that disease to get started. If it gets started early enough, it can be really devastating. So that's certainly, when I talk to farmers, there's not a lot of diseases that will completely change management practices. Mm-hmm. This is one of them. If you have a bad white mold outbreak, you probably are going to do things differently in that field moving forward, because you don't want to experience that again.
Okay. The organism that causes white mold, does that impact other kinds of plants?
It can. Agronomically, there's not a lot in Iowa, at least or in the Midwest. But if you get outside of Iowa, it can cause problems on sunflowers, canola, dry beans, etc. It has a really wide host range, and so that again, like one of the IPM strategies for some farmers is rotation, and that's something you'd have to think about. Like, well, does this pathogen infect multiple crops? You can't go from soybeans to sunflowers. That would be a bad rotation, for this particular disease.
You're just going to grow the white mold instead of the crop you want.
Right. Yep.
As you mentioned, monitoring is an important part of the integrated pest management process. So, are there tools that farmers can use to help them monitor white mold?
Well, the best tool is to get out and scout. And there's a couple of different things. You could say, well, just scout, plants like this and look for the symptoms, but that might be too late. And so one of the things you could do is go out and scout and look for those apothecia, look for the mushrooms, and that would indicate like, hey, you have a higher risk. But there are tools out there that just are for disease risk modeling. And so Crop Protection Network has a really good tool where you can go on, sort of put in your information, pick your row spacing, and sort of put in some of the parameters of your field, and then that will give you an idea as to how much of a risk you have in a particular area or in a particular field. And so that would sort of, once you decide that, you can use that information to sort of make in-season decisions for management.
Okay. You can kind of tailor the program to your specific field, your location, and then it will take into account the weather that's been happening. Does it take into account?
It's usually the weather actually the last 30 days. So you're trying to figure out, are the apothecia producing?
Okay.
So that model is actually looking at apothecia production.
Okay, great. And farmers can use that to then get out there, look for the apothecia, make the management decision based on that instead of out there all the time scouting?
I mean, apothecia are hard to find. I would say if you have somebody that you're paying somebody to look for apothecia, great. That's the gold standard. Okay. If you don't have that, use the model and that should give you a prediction as to if it's likely that they're being produced or not.
Okay. So what are some of the key takeaways that you can tell us about IPM, white mold, and the NRCS?
Yeah, so I would say the first thing is that IPM is not just about management decisions. It's about gathering information. It's about pulling a lot of moving parts together, and it's trying to manage a crop or a pest the best you can with economics, with the environment, with human health in mind. So it's a fairly complicated concept, but you have an end goal of being as responsible as you can be when you're trying to manage that problem. All right, and then sort of summarize white mold in that regard. This is probably one of the most complicated diseases, and managing this disease does take scouting or knowing your information, knowing the history of the field, being prepared on that end, knowing the disease cycle. Are there ways to manage the sclerotia? Are there ways to manage having the apothecia not develop? Are there ways to protect the plant? Picking a resistant variety. There's a lot of different strategies that you can all pull together and try to sometimes you're not going to eliminate the disease, but you try to minimize the risk for disease developing.
Well, thank you for educating us on IPM and white mold and how that relates to the NRCS, Dr. Mueller.
All right, thank you.
Understanding risks to your field is an integral part of integrated pest management for crop diseases. By keeping track of which diseases have historically posed an issue to a crop in a specific field and what predicted risks are, farmers can get a leg up on disease management before these diseases become an issue. This approach conserves yield while helping to protect the environment and human health. White mold in soybean is a disease where knowing past and future risk is essential. This disease can result in severe yield losses if not effectively managed. The fungus that causes white mold survives in the soil as small, hard fungal structures called sclerotia. When soybean plants flower, sclerotia produce mushroom-like growths that release spores. Spores infect soybean plants through the flowers and can destroy the plant. If white mold is detected in a field, it will likely be an issue in that field in the future. Noting this and keeping track of the data will help farmers select cultural management practices for future growing seasons, such as choosing resistant soybean cultivars. Predictive tools for white mold risk are also available through the Crop Protection Network. These consider location and weather to alert farmers when they should scout for white mold, which in turn helps to time fungicide applications. Applying fungicide only when needed helps save money and minimize the risk to non-target organisms, while also protecting crops. Be sure to scout after the application, considering the re-entry interval following the spray, and assess whether the treatment was effective. By keeping track of field history and utilizing disease warning systems, farmers can implement effective white mold scouting and management strategies. These tasks align with various NRCS 595 standards for routine scouting, utilizing land-grant university information, incorporating previous season scouting reports, basing fungicide applications on actual disease risk, and determining treatment effectiveness through post-application scouting.
We've seen how IPM can help protect soil health and manage diseases, but it can also be critical to supporting the life within our field, such as beneficial organisms or pollinators.
Hello, my name is Adam Sisson, and I'm with Iowa State University's Plant Pathology, Entomology, and Microbiology program. I'm with Dr. Laura Iles, who is with the same program on campus. Dr. Iles here is an expert in entomology, and so we're going to dive into the insect aspect, pollinators, beneficial insects, and how that relates to the various conservation practices or pest management practices in fields. All right, to start with, what is integrated pest management or IPM?
So integrated pest management, obviously we know that acronym stands for, but encompasses a lot of different management practices with the goal of maintaining profitability and then avoiding ecosystem consequences. So one of the things that NRCS uses is that they kind of conceptualize it, we call the PAMS approach, which is prevention, avoidance, monitoring, and suppression. So focusing on those aspects of the pest, and obviously prevention, keeping plants healthy. You can look at cropping times for avoidance. Monitoring, scouting is huge. And then I think suppression is a good term, especially for insect pests, because we can't really control all the pest insects in a field, but we look more at suppressing it below certain thresholds. When we think of integrated pest management with insects, that's when we kind of get looking at the environmental impact of looking at insecticides and things, and how do we reduce that? Because of course we have lots of insects that are very beneficial to us, and we want to try to protect those as well.
All right, thank you. So you mentioned beneficial insects. Why would a person want to protect these beneficial insects? What are the ecosystem services they provide? Can you talk about that?
Sure. So we'll start kind of with what are beneficial insects and then talk about the ecosystem that they're in. So pest insect, to start with, I think we all know what that is, but a pest insect is one that's interfering with something that we like. It's eating our crop. We don't like that. We call it a pest. Beneficial, it tends to be a term for insects who are doing something that kind of literally benefits us, that we like what they're doing. And so there's a lot of different kind of categories in those, like what we would call beneficial insects. So pollinators is the first one most people think about. And pollination benefits us. We love apples, we love almonds, we love all these plants. And so we rely on pollinating insects to move that pollen between the flowers and make sure we've got good fruit production. So that's a big category of beneficials. The next probably big category that we think about is the predators and parasites. So these are insects that eat other insects. And because they're eating other insects, they often eat pest insects. Think of like soybean aphids and things like that, where lady beetles and hoverflies are eating a ton. So those predator and parasites are huge beneficial insects. Of course, we don't talk a whole lot about it, but with NRCS and of course the importance of soil, there are so many insects and other organisms in the soil helping break down organic matter and keep those soils healthy. All of these things are in the same kind of agro-ecosystem as the pest insects. So all of the practices that we're doing can impact them as well, and that's why it's so important with IPM practices to be considering those beneficial insects.
Beneficial organisms, they probably need more than just the single crop that is oftentimes growing in a row crop field. Can you tell us a little bit about what they need to thrive and what they need to actually help farmers manage some of these pest insects?
Of course, and I think that's the most important part, is thinking about the ecosystem approach. So we'll start kind of say with and insects are just like any other animal. They need food, they need kind of a place to raise their young, they need shelter. And so these encompasses lots of different aspects. So we'll start with pollinators. So just because of the name, we think of them as they're in a flower and they're feeding on pollen and nectar. But the reason they're doing that is they're taking that pollen and nectar back to a nest. I mean, if they're the European honeybee, they're going back to a hive. They're using that nectar to make honey, to feed their young. So they're not just in the flower. So I think that's the important part, is to realize they're not just in that flower. They need a place to have their nest and to rear their larvae, things like that. The predators and parasites are obviously really interesting. It's often with parasitic wasps are really common in flies. Their larvae are what are feeding on the pest insects and the aphids or the stalk borers and things like that. But as adults, they're actually pollen and nectar feeders themselves, so they need those resources there in the ecosystem. They can't just have the pest. And so most of our insects are like that, where they might be nesting in the soil, they might be nesting in old dead stems over the winter. So thinking about where they are when they're not kind of in that moment of benefiting us, what are their other needs and how do we make sure we're protecting them throughout their entire life cycle and throughout the year.
Dr. Iles, what role do beneficial organisms play in an IPM system?
Beneficial organisms play such a key role in these IPM systems, and I think thinking back to that PAMS approach, it's the suppression that we normally think about. So I mentioned soybean aphids earlier. That's such a great example of a pest system where we've got aphids all over the soybeans. A grower monitoring them, hitting certain thresholds. Well, aphids are just great food for a lot of different predators and parasites. So we have parasitic wasps that feed on them. We have hoverflies whose larvae are on those leaves feeding on them. Of course, lady beetle larvae, lacewing larvae. So all of those organisms are kind of naturally there. We actually call that natural biological control. We're not having to come out and release these organisms. They're just here in the environment, and our only job is to try to protect them and make sure that they're there. And frankly, we have no idea what our pest problems would be without them. They're just there. They're always suppressing. They're always giving us a hand. I can't imagine what a pest like soybean aphid would look like if we didn't have all this natural biological control naturally suppressing it all the time.
Now, I've heard that there are instances where the application of a pesticide can actually cause an increase in the organism that you're trying to manage. Can you talk about that a little bit?
Correct. That's not uncommon at all. And again, it's because, so you apply an insecticide and you're trying to kill the pest organism. It often doesn't work. I mean, pests are pests because they're pretty good at avoiding, it's very hard to have 100% kill. So you'll have some of the pest organisms survive. And oftentimes those pest organisms can reproduce pretty quickly. Again, back to that soybean aphid. Those females can clone themselves. They can have daughters in days, and the populations can build up quickly. Whereas, like say a lady beetle larva that feeds on them, those two adult lady beetles have to mate, they have to lay eggs. Those eggs take, a week or so, they have to hatch, and then you have a larva, and then that larva would start feeding on the aphid. So there's such a delay with it. And so that's why oftentimes we see an insecticide come in. It kills, a good percentage of the aphids, but it kills a lot of the larvae and all the beneficial insects. And then those aphids are so good at roaring back, and the problem being even worse because you've kind of completely hampered the natural biological control that was occurring.
What are some ways that NRCS IPM programs help beneficial insects?
So in a lot of different ways and a lot of different practices that NRCS has put into place that are so beneficial. When I look through that list as an entomologist, I see kind of like overall just education and knowledge as well as pesticide application methods. I see all the kind of scouting and monitoring methods that they have, and then finally all the production practices that help protect beneficial organisms.
So there's kind of three different categories that these strategies fall into.
Yes, kind of three broad categories that you can think about, and we can walk through each one.
Great, let's break it down. Can you tell us about the first one, please, which was general practices, I believe?
Yeah, kind of education and pesticide practices. So one of the really important things to NRCS is maintaining knowledge, purchasing field guide books to insects and diseases, and knowledge of what pests are likely to be problems. So that kind of continuing education and knowledge is so key. And then part of that is also maintaining your pesticide applicator license if you're applying pesticides. And then when it comes to applying those pesticides, there's a lot of different steps that can be taken and that are part of that NRCS program. Things such as selecting a pesticide that maybe isn't as broad, less likely to kill the beneficial organism. Yeah, picking those selective pesticides, picking ones that maybe don't last as long out there, maybe a little less residual impact can also help the beneficial organisms. Things like kind of spot spraying. Sometimes pests like, Japanese beetles will be in a certain area of the field. Can you just kind of treat that area? Certainly with weeds, can you focus the herbicide use on kind of the specific area where it's bad, so not just treating the whole field. Even like nozzle calibration and stuff are so important to prevent that drift and things like that, drift into areas outside the field where certainly beneficial insects will be as well. So those are all just good practices that also help the beneficial insects.
Right, so a lot of education, knowledge gathering before the season even occurs so that you know if there are
new and better practices or products that you can use in your fields. You're possibly aware of invasive organisms or potential dangers for this field season. So it's basically a lot of preparation work so that you are more adequately prepared for the season.
Yes, and I didn't mention record keeping is one that I think is probably not like super fun, but like, what did you do? What did you treat with? Did it work? Did you notice non-target impacts? Did you notice a flare-up of aphids after you used a certain product? But yeah, this is the time of year and after harvest and stuff where you're thinking about all those things and what you can do next year.
Right, so you have knowledge of what's been in a field so you can help be more reactive to it.
Correct.
Prepare for it instead of reactive.
Yes, yep.
Great. So now that, let's say your crop's in the field, it's coming up. Now, how do you find out about what's an issue this year?
Correct. So scouting and monitoring, but I will also add maintaining that kind of education. Make sure you're subscribing to newsletters and things like that, because again, those invasive insects are things every year is a bit different and you don't know what's going to flare up. So a little bit of just awareness in your region of what might be seeing, but then going out into the field, and it's that scouting and monitoring, routine scouting and monitoring that's so important to these NRCS IPM programs, where you're checking the plants for any insect pests and the diseases. And again, you want to have that knowledge of, okay, what am I looking for at what times of year, what diseases are likely now, or what insect pests are likely now. So you kind of have that search image as you're going out and doing that monitoring. And then when you notice something like, okay, I've got, this disease, is it time to treat? Is it too late to treat? Making those decisions. But you've got that kind of foreknowledge by getting out there, and then you can make those treatment decisions if something's crossing a threshold.
So perhaps an example of that would be with black cutworm, where it doesn't overwinter in the Midwest and instead has to fly up as the adult moth from more southern states. And there are people at universities who monitor when the moths are arriving. And then so like paying attention to your extension newsletter would help you understand when the moths are arriving. But then you have to get out into the field to see when the eggs that those moths are laying hatch and turn into larvae that could be capable of cutting your corn. And would that be an example?
That's a great example. And it just shows you with even one pest, like the knowledge and the kind of almost community approach we take to it. Like again, monitoring, and we have many universities will have cooperators that are putting out those pheromone traps and checking them and counting the moths and letting us know. But then, that's that individual into your farm. What is your risk? What hybrids have you planted? Are they at high risk? Do you need to make that treatment? So it's a lot of knowledge of like a large number of like insect pests and the weeds and the diseases. So it's not easy, but that's why, record keeping experience and time really help with these integrated pest management programs.
Great. So we also know that, for example, armyworm can be an issue in crop fields where there's been grass cover crops or nearby areas that aren't crop fields. The armyworm can move from one of those sources to another. Let's say a farmer comes across a situation where there are armyworms in his field. What options does he have?
Right. So and again, then we're looking at like, okay, we've got a pest, I've got a crop in the field. Then you first probably, most farmers will look at is like, what are the economics of it? Like how much of my crop is being damaged? Do I have access? Do I have the ability, can I spray with, drone or flying or a ground, is it too late for ground treatment? So there's a little bit of the logistics. Can I apply a treatment? But if you can, then looking at, is that going to be an economic payoff? Should I? Yeah. Will it protect the crops enough that the yield protection pays for the cost of doing that treatment? And then when you decide like, okay, yes, and then doing that treatment, something like armyworms, could I use, a BT product that's specific only to caterpillars and isn't going to harm other things? And the unfortunate part, and that's why the scouting is so important, is sometimes these things have caused quite a lot of damage before we even notice. And, that's where, if the caterpillar is large, it's already done most of its feeding. We call that kind of revenge spraying. Like it might kind of feel good, but are you really preventing much more damage? So armyworm are always an interesting one because of that.
So what are some production practices that could help
with pests in the first place to prevent them from occurring?
So I love the production practices because I think in many ways those are the most important. Production practices are a lot about just keeping plants healthy, and healthy plants can be resistant to diseases and insects. Anything that just help keep our plant healthy is great in that integrated pest management system. Some specifics, though, for insects would be selecting hybrids that have resistance to certain common insect pests. So if you know you live in an area, or you know you've had a problem with this, selecting hybrids that are appropriate for that. Again, if the hybrid is resistant and you don't need to use an insecticide spray, you're protecting the beneficial insects because you're not putting a spray out. Some of the things to think about, seed treatments, maybe not using them or using ones that don't have a neonicotinoid. I mean, we've learned a lot about how the neonicotinoid insecticides can have impacts on pollinating insects. So, if it's feasible with your cropping system and the pests that you're managing not to use a neonicotinoid, that's another way that can benefit the beneficial insects. Tillage is hugely important. Like, we didn't talk a ton about it, but again, all this corn stubble and things like that, we could have pollinators overwintering in there. We could have underground nests with lots of the wasps and things will nest in the ground. Hollow stems will have nests. So reducing the activity in the field kind of, through the winter really can help benefit. So kind of those no-till systems are beneficial. And then finally, one that, a lot of growers are doing is planting, pollinator strips in areas kind of between fields and things like that, planting plants that flower throughout the summer, providing that pollen and nectar, again, for the pollinators, but particularly for those parasites and predators that really need them in order to increase the biological control in their fields.
And so maybe they could put those pollinator strips in areas where the row crops haven't traditionally done well in a field. So kind of the unproductive land could be converted into something that could help beneficial organisms.
Yes. So those prairie strips can be beneficial, of course, with runoff and erosion and things like that as well. But yeah, putting them into flowering plants is a huge benefit to all those beneficial organisms.
Well, thank you for explaining how IPM relates to NRCS, Dr. Iles. We appreciate your time today on this very cold November day in the Midwest.
My pleasure.
Scouting crops is a fundamental practice in integrated pest management for insect pests. By monitoring the fields regularly and systematically, farmers can identify pests before they reach damaging levels, enabling targeted interventions instead of blanket pesticide applications. This approach conserves beneficial insects and protects the environment and human health. The black cutworm is a pest where scouting is essential for management. This pest can damage young corn plants by cutting them at the base, which can lead to stand losses. Key methods for timing scouting efforts are monitoring adult flights and then calculating degree days. Peak flight refers to when adult black cutworm moths are most active. Farmers can use pheromone traps to catch moths, helping to predict when eggs are likely to be laid in fields. Degree days measure heat accumulation over time, allowing farmers to estimate pest growth stages. Calculating degree days helps determine when black cutworm larvae are likely to be big enough to start damaging corn, signaling the best time to scout fields. If black cutworms are found in a field, farmers should use a university-recommended threshold for determining if the risk of injury is enough to pay for or even warrant treatment. For black cutworm, the university-recommended threshold depends on larvae size and the number of injured plants. Even if a threshold is reached, spot applications may take care of the issue rather than spraying the entire field. Additionally, it is useful to scout after the application, bearing in mind the re-entry interval post-spray to see if the treatment was effective. By monitoring peak flights and using degree days, farmers can time scouting efforts for black cutworms and use a treatment if a threshold is reached. These tasks line up with various NRCS 595 standards for routine scouting, using land-grant university information, timing insecticide application when scouting and thresholds indicate that it's necessary, and determining treatment effectiveness through post-application scouting.
So we've seen how these integrated strategies can help protect our natural resources, but how do we put them into practice? This is where the NRCS comes in, although they use a slightly different terminology.
If you go into the NRCS and start looking for IPM, you're not going to find very much, and that's where some people get very confused. And so you have to look at their terminology, which is PAMS: prevention, avoidance, monitoring, and suppression. So if we look at prevention, this would be just preventing them from getting in the fields in the first place, whether it be planting timing, varieties, using trap cropping to prevent them from coming in, using whatever tools it might be to prevent them. Avoidance, similar things. These might overlap with IPM. The right varieties at the right time, doing it rotationally, long-term rotations, whatever that might be. Monitoring. Now there's a couple different types of monitoring you can do. Much more passive monitoring, use pheromone traps, see what's around. Or active monitoring. You actually go out in the field, you use your sweep net to see what's out there. You'll do insect diagnostics for going in and doing soil sampling, or you're actually doing leaf sampling and seeing what there. You're going to look for the disease pressures. You're actually going to take data, manage that data for the long term. You're actually monitoring out there. And then the suppression, where you're actually going to do some kind of management. And I think you've heard this in a lot of the videos, but what those management techniques are, it's not just the chemical controls. It could be the biological, it could be all these cultural controls, it could be the tillage, it could be movements. It's all these different things, but whatever it is to suppress the pest. But when you look at that, you can link all these IPM terms together, and it's the matter of how do we actually develop our IPM plan to link it together. So a good step to start is to actually sit down with somebody, start developing your IPM plan on whatever cropping system you're out there to look at. Develop what pests of concern that you have, what are your key pests of concern, how are you going to manage that, what are your first steps to do it? Are you going to just start by seeing what's out there? How are you going to manage it? How are you going to monitor it? How are you going to scout for it? What are you going to do? What are some of the planning options you can do to minimize it in the first place? What are some of the IPM options to minimize it, to avoid it? Are there different varieties that you can do? Can you use cover crops to avoid it? Can you use longer rotations, whatever it might be? And what are other ways to prevent it, to monitor, whatever? And then if we do get to that point of having to do some kind of action for it, what can we do? What are the chemical options, but what are the other options that we can do? If we do have chemical options, do we have resistance concerns? Which many of them do, whatever they are in your cropping systems. If there are resistance concerns, what do we need to do with that? How can we use that in a proper resistance management strategy, alter our modes of actions correctly, make sure that we maintain those kind of chemistries in the system as long as possible. So again, once we have that plan, make sure that we're doing it properly. It's in there for our state with our state-based recommendations, and start planning that way.
We've heard from Deana and Dan about a roadmap for creating a 595 plan. Now, let's listen to an NRCS state agronomist talk about IPM practices and how they contribute to meeting NRCS conservation goals, as well as farm management goals.
Hi, I'm Deana Knuteson with the IPM program at UW-Madison out of the Department of Plant Pathology, and I'm here with Jamie Patton, the state agronomist with NRCS in Wisconsin. And today we're going to talk about the IPM program and its links to some of the things that they can do. Growers can start with the 595 plan. Can you talk to us about that?
So when we think about IPM, so integrated pest management, there are a lot of opportunities to look at NRCS and some of the programs and some of the practices that we have to integrate into an IPM plan before we ever get to 595, which happens to be pest management conservation systems. So as we think through our IPM plan and that integrated approach to pest management, we have the opportunity to utilize practices such as cover crops that we're standing in here today, to use that for weed suppression. We have opportunities for conservation crop rotation. We have nutrient management, right? We have all sorts of practices that we can utilize to control and suppress some of those weed, disease, and insect pests. We also have a specific program called 595, again, Pest Management Conservation Systems. And that is going to take a PAMS approach to controlling and suppressing pest management. And so it's prevention, so PAMS stands for prevention, avoidance, monitoring, and then suppression. And so depending upon state to state, where they will emphasize what part of that PAMS process they're going to utilize in their program approach. In the state of Wisconsin, for example, we really like an integrated approach. We want producers to think about those prevention and avoidance activities prior to thinking about suppression, right? So can we put practices in place to mitigate some of those issues that we might see with crop production and those pests, whether it be on large scale or small scale, so raised bed gardens, CSAs, things along those lines. We also emphasize monitoring and thinking about that scouting and making sure that we're looking at the frequency and intensity that we want to utilize to really get a good feel for what pests are out there, the proper identification, whether or not we're meeting those threshold levels that justify the economics of spraying or suppressing those pests. And we also want to think about that crop scouting, really thinking about how we can look at variable rate technologies, for example, or spot spraying to utilize our pesticides and our suppression activities in a manner that are not only going to be economic but environmentally friendly. And last but not least, we think about that suppression, right? And so that may be physical, biological, and of course we all think about that chemical suppression. And so helping producers with some of our software think through those chemical pesticides that we're going to be utilizing. Do we have opportunities to reduce drift, opportunities to reduce risk to groundwater as well as surface water? And so it's really a comprehensive kind of look at pest management on the landscape. And because of that, when we think about it from a producer standpoint, not only am I going to increase potentially my economics because I have a better feel for what is out there in my field and whether or not it justifies, I am justified in spending the money for suppression, but also how can I utilize some of those new techniques that may not cost me anything, right? Really paying attention, for example, choosing transplants or seeds that are pest-free to begin with, right? So suppressing those weeds just by avoiding them. So there's a lot of economic incentive, there's a lot of crop benefit incentive, and of course there's an environmental incentive for all of this.
Sounds like there's a big overlap with working with the university then and getting their resources for some of these things from scouting and from the management practices in their IPM programs.
Without a doubt. So this is a science-based approach to pest management. So we rely heavily on our land-grant institutions to provide us that guidance on what that, for example, that scouting intensity and frequency should be for particular crops, particularly when we think about some of those specialty crops. Are there new apps? And I know universities, working with the universities, there's apps and modeling technologies that can help us with some of those pest management decisions in some of our crops outside of corn and soybeans, whether that be cranberries or fruit crops, so on and so forth. So the universities, the land-grant universities, are integral in helping us make those decisions to make pest management effective as well as profitable for that farmer.
How do you see these kind of programs, these IPM programs, or the work that you do at NRCS with these kind of things, work with the overall NRCS resource goals that are out there?
To me, it's an all integrated approach. When we think about the title, right, Pest Management Conservation System, we're looking at this not only from a crop production standpoint, but we're also going to be talking about beneficial insects, right, pollinators. We're going to be talking about water quality. We're going to be talking about air quality, wildlife benefits. So to me, it's a comprehensive approach looking at that natural resource management, but really honing in on that pest management strategy as part of our agronomic system.
Yeah. What about growers? Are they going to see a return on investment either immediately or long term, or is there economic benefit for them to start this now?
I believe so, right? And when we think about this, for example, we know in this state, we have herbicide resistant weeds. They're prevalent on our landscape. So making sure and working with the NRCS to set up that scouting protocol, right? Making sure that we're ahead of the game. Working with NRCS and our trusted crop advisors to select herbicides, to look at the timing of that herbicide, right? We know that, for example, pesticide-resistant water hemp can reduce yields by maybe 30 to 50% or more. So can we get ahead of the game? And hopefully, like I said, if we are identifying those pests properly and we're identifying those economic thresholds and we're identifying the proper strategies for suppression, we hopefully will see that profitability and that return in that first year. Our roots are in the soil conservation service, right? Mm-hmm. Those hard practices, when you look across the landscape, waterways and terraces, mm-hmm. and things along those lines. But through NRCS, we are technical experts, right? We would love to work with farmers and provide that comprehensive approach to nutrient management and crop production, looking at how these practices can integrate with those farm goals, not only to help the farmer achieve his or her goals for crop production and for resource management, but also the larger resource goals of society. And so it's truly an integrated approach, right? That's the whole idea behind soil health and soil health management.
As we wrap up here, is there anything else you want to tell us about how NRCS can work with growers and help them with their IPM programs?
I encourage producers to come into the local NRCS office and talk with us about our pest management conservation system practice. There's a lot of opportunities to look at those practices that have been vetted by not only the Land Grant Institution, by NRCS, as well as our industry professionals to help us manage pests better on the landscape to not only achieve not only our producer goals, but also our environmental and conservation goals as well. So there's a lot of opportunity to step into IPM and make our farms more profitable as well as sustainable.
Sounds great. Thank you very much.
Thank you, Deana.
We've learned that IPM is about using many little hammers, like planting cover crops or strategic harvesting, to manage pests effectively. We've seen that these practices don't just help protect our crops, but also help protect our shared natural resources, like soil and water. And importantly, we've learned that the NRCS is here to help through programs like EQIP and the 595 Pest Management Plan.